One of the most important theory in bonding is electro-neutrality principle. Electro-neutrality principle. Electro-neutrality principle. So how that electro-neutrality principle is comes from and why? Because in valence bond conception or valence bond adaptation, there is some difficulty as the ligand donate electron to the metal ions of thermal negative charge on the metal ion. Metal ion can occupy thermal negative charge when the electron pair is donated from the ligand. As for example, suppose if we consider a complex cobalt 2 complex such as COL6 2 plus. This is a complex. Okay, this is a complex. So the six ligands share 12 electrons. Six ligands share 12 electrons with the metal atom, and this process results in the thermal charge build up to -6 on the metal. So suppose six ligands come to the cobalt. So this ligand donated their electron, and then -6 thermal charge generated. -6 thermal charge generated on metal, which is partially satisfied by the ionic charge of metal. Ionic charge of metal, that is +2. So metal has a +2 charge, so this can partially cancel or partially satisfy. Okay, so thermal charge point of view, cobalt would become negative. So if we consider about the thermal charge, then cobalt should be negative. That's why Pauling first pointed out two reasons. What are the reasons? Now, why metal would not in fact exist with such an unfavorable negative charge? Why metal would not in fact exist with such an unfavorable negative charge? So, why metal not exist? Because in first we can say donor atoms of the ligands are in general high electronegative atoms because nitrogen, oxygen, sulfur, fluorine, chlorine, etc. halogens. So, high electronegative element. The bonding electrons will not be shared equally between the metal and the ligand because the bonding electron not totally equally shared. Thus, inducing the positive charge on the metal to help it offset the unfavorable thermal charge. Because if the total electron shifted to the metal, then metal become negative charge. But this is not happen actually. Because more electronegative element has tendency to attract the electron pair towards itself. So ligand can occupy the electron towards on it. As a result, there is no induced positive charge to the metal. So what Pauling suggested? Pauling suggested that complexes would be more stable when the electronegativity of the ligand was such that the metal achieved a condition of essentially zero net electrical charge. This is known as electro-neutrality principle. So what is electro-neutrality principle? Very important. What is the principle? So this principle was suggested by Pauling. What is his suggestion? The complexes would be more stable. According to Pauli, the complexes would be most stable when the electronegativity of when the electronegativity of the ligand was electron-neutral ligand was such that the metal achieved a condition of essentially a condition of essentially zero net electrical charge. Zero net electrical charge. This rule is known as electron-neutrality principle. That means the complex will be most stable. One complex will be stable when the electronic ligand was such that the metal achieved condition zero neutral charge total. So Pauli and his co-workers, what they have done, they have some semi-quantitative calculations and correlate the stability of different complexes. And based on these methods, they have suggested that whether a metal complex will be stable or will be unstable. So there are some typical examples are there. Suppose as for example, I consider two examples, very good example. Suppose Be H2O whole 4, 2 plus. This is a complex. Another one is BeH2O whole 6, 2 plus. So among this complex, which one is most stable? So you have to think about it. Okay. So in both cases, beryllium has plus 2 charges. So if beryllium has plus 2 charges, so that oxygen on water molecule donates the electron density to the beryllium. So when 4 water molecule donates on the plus 2 charge of beryllium, then beryllium can be partially neutralized the electron density between water and beryllium. But when 6 water molecules donate to the beryllium, then extra negative charge takes place or happen or remain on the beryllium. As a result, BeH2 whole 2 plus is more stable than BeH2 whole 6 2 plus because 6 water molecule makes so much negative charge that 2 plus charge is not fully satisfied by the beryllium. But when 4 ligands, that is the number of ligands is less, so this can be satisfy the charge formal charge by plus 2. Similarly, so BeH2O whole plus is more stable than BH2 whole 6 2 plus. Similarly, suppose there is an example AlH2 whole 6 P plus versus AlNH3 whole 6 3 plus. So here ligand one is water, another is ammonia. So the nitrogen donor of the ammonia ligand is not sufficiently electronegative to build excess electron density on the aluminium. That's why, but water is more electronegative, so it can build negative charge on aluminium, which can be satisfied the high positive charge of plus 3, where nitrogen cannot accommodate that type of charge. That's why according to electron-neutrality principle, aluminum hexagon complex is much more stable than ammonia because ammonia is less donor. Similarly, suppose if we consider about copper, CuF6 P minus is stable. Similarly, MnF6 2 minus is stable because plus 4 charge fluorine is high electronegative. So that high electronegative fluorine can partially neutralize plus 4. Similarly, copper is in plus 3 states of 6 fluoride can stabilize. As well as MnO4 minus, that oxygen is more electronegative, but it can stabilize the plus 7 oxygen states. That means it is possible to find metals with high oxygen states in oxides and fluorides complexes. So why we always obtain high oxygen state present only for oxide or only for fluorides? So that can be explained by the electro-neutrality principle that more electronegative atoms like fluorine and oxygen, they can stabilize the higher oxygen state compared to the other ligands. So that's why this is according to electro-neutrality principle, more stable these complexes. That's why chlorine and oxygen always form high oxygen state complexes. Okay. Similarly, pi acid ligand like carbon monoxide always form stable complexes with metal zero or low oxygen state because carbon has very less electronegativity. So when it donates to the metal or it bonded to the metal, it cannot create any negative charge on the metal. That's why all carbonyl complexes are generally zero or negative oxygen states. For similar way, we can explain from the electroneutrality principle, we can explain NiCO whole 4 exists, but ZnCO whole 4 2 plus do not exist. So this also can be explained by the electroneutrality principle because nickel is zero oxygen state, so carbon monoxide is a neutral ligand, so it can stabilize the zero oxygen state of nickel. But when the zinc is plus 2 charge, so neutral carbon monoxide cannot stabilize that plus 2 oxygen state. That carbon monoxide cannot give too much electron density on the metal. That's why ZnCO4 does not exist according to electroneutrality principle. So this is the basis of electroneutrality principle. Electroneutrality principle means electronically neutral molecule. That means the ligand have more electron density on it, so it can stabilize higher oxygen state of the metal. When the ligand has less